Texas Center for Applied Technology?
I'm Nick Juarez. I'll be graduating this May, but I do not have a job yet, so.
And I'm Zachary Dom, and I will be graduating in May also, and I do not have a job currently.
And we are the TAMUscheduler app.
So the TAMUscheduler app is an automated class generator for Texas A&M students. What's its purpose? So, students are often faced with scheduling the classes manually, going through the typical process of writing everything down, and that can be tedious. So, TAMUscheduler intends to provide students with a tool to address these issues and make this more optimized and efficient process for students.
So like you said, the TAMUscheduler app is a student companion. It's meant to be used, I guess, every semester when students are starting to register for classes, or whenever they're starting to plan for classes for the next semester coming. Normally, when you're signing up, we have to use a system called Howdy. I don't know if you guys used that back when you graduated, but
you don't have to wait in line at the pavilion with paper clips.
Oh yeah, we use a system called Howdy, and it's got a lot of. You basically just get a list of classes, and you have to go through each and make sure that the prerequisites are right, and the times aren't conflicting and stuff like that. Basically, our app will take your previous courses, your planned courses, and your availabilities, other metrics like that, and then automatically generate up to 5 schedules at a time, and then give you the class numbers to sign up with. We target Android OS, and we can run anything above API 16 Jelly Bean. So it'll run on, I think it was 97.5% of devices out there right now. It's mostly meant to be a mobile app, so probably not like Android TV or anything. Scalable graphics and objects allow it to run on most devices little to no problems, because it will scale the app down and run nicer on things with less processing power. It also uses an external database and server to make sure that the app isn't storing excessive amounts of data or putting a strain on the user's phone or other device.
All right, so Chad kind of touched on it before, but maybe it was worse for you guys, but even today.
You don't have to keep dating that night.
Yeah.
Really.
But our main reason for making this app is because we all agreed that the current tools that are available to TAMU students aren't adequate. A good example of that, this is our TAMU class search on Howdy, and it's basically the only way of getting detailed information about courses. And it requires you to select basically the only criteria that you can search based on is a subject, and then it'll give you a list of courses, and that detailed information, but that's the only criteria that you can base your search on. It's very impersonal and very inconvenient.
And you have to I always had to make an Excel spreadsheet and write down, the various class times in order to make sure that they wouldn't conflict with each other.
And one other point, you can only, when you're viewing a course, move back one real quick. When you go and view sessions for a course, you can only view one course at a time. So, if you're trying to meet some credit that has, different options, you can only do one course at a time. See if it works for you, works for your schedule, has spots open, and then kind of go from there. It's a tedious process for sure.
One big thing I always had to not look forward to is the fact that whenever it opens the registration time, everyone has to put in their CRNs at the same time. And so it's a mad dash to get the class, and maybe slots fill up. So you have 5 options now. You can just take your CRNs that you're given and plug in new ones.
So planning and analysis, we started by conducting interviews from 5 different majors, where we make sure to identify these issues, to make sure that the problem we were trying to address was actually there. After identifying the issues, we found out that obviously it takes an excess amount of time, which we've already addressed, and inability to graphically view and efficiently build these schedules. So this can lead to lead to poor schedules that can affect your semester or how you perform. So in order to accomplish this, we had to do several in-depth analysis, data, resources, and overall, this was feasible. So this was our mock-up design of what we wanted and the different criteria that we needed to get, so that when we finally got to the development process of implementing this, we weren't worried about what it looked like or how to do it. what it looked like or what we wanted in there, but just how to do it and make it work so that we could provide this tool.
We wanted to provide everything that we think the current methods lack, but then beyond that, combine it into one system, because there are a few other available resources out there, but none that are consolidated into a single system.
And this is our data flow, and the best way to do this is, if you look at the application database, it's kind of like a median. So the way it works is, obviously we have our app, it comes over here, we get some other information from our refined data we pull from the database. We can generate these schedules. But in order to get that, we have to use, we were given some dummy authentication to go through text in our website, scrape some data, pull it back, and then put it into the database. And that's essentially just a really simplified version of how this works. And moving forward to implementation.
Okay, so to implement this, we used agile development, and we basically were a multidisciplinary team. I've already built an Android app before. None of these guys have, but they are used to programming. Obviously, they're computer scientists. So we each to their own, each who's best at whatever they are best at. We assign them tasks, I guess, and no one person is a leader, so we all just kind of agreed on who would do what. So we had a close collaboration between parts, like the database had to be interacting with the server, so whoever's coding the server and whoever's coding the database had to be together a lot. We spent the first bit of every meeting talking about what we've changed, pushes to GitHub, that sort of thing, any bugs or hurdles we've faced when we haven't seen each other in a while. We use GitHub and Git integration in Android Studio to push the code to the cloud to make sure that we can execute from anywhere. And then we use, for data handling, we had to figure out a way to pass data through the app and how to store the data, web scrape, and do the database implementation. And for optimization purposes, we planned out the overall architecture before actually coding it. We made packages, the layout of the packages, we made the methods for how we'd handle the data, that sort of thing, before we'd actually program it to make sure that there was no spaghetti code or any sort of misunderstandings in that. Okay, so on the first screen, you will load up the app. It actually loads something that doesn't look like this because it's a splash screen. It loads that so that there's no blank screen in case there's load time. But then you're brought to this once it's finished loading, and it was actually too fast for us to get a screen capture of it. We tried, but you just hit begin, and then you're brought to the getting started page.
All right, so there are 4 main pages in our app. Each is designed to personalize the user's experience. And each, besides the first, builds off the previous. So this is the first one, the getting started page, and it has the user input their degree, which determines what degree plan we're evaluating, essentially. The desired number of credit hours, so that after they've entered, the credits that they plan to take, we can fill in the gaps and meet, that sort of criteria. And then their weekday availability. Any conflicts with their, availability for any day will be checked against the suggested courses, and if it doesn't work with their schedule, it'd be removed. And so then the next page is the previous courses, which, based on their user input of the major, loads up a list of the guaranteed courses in the degree plan. There are certain credits that can be filled by different courses, like international cultural diversity, humanities, but the ones that are absolutely required were listed here for the sake of convenience. And then the user could select which courses they've taken, and then perform a search, which sends queries based on the subject and then the text to find and select courses that don't appear on the list. And then based on that, on the next screen, in planned courses, it would evaluate from their degree plan which courses they have taken or are ineligible to take based on the prerequisites. And then provide the user with another search, allowing them, drop-down allows you to select either a credit, such as ICD or humanities, or if it's another like absolutely required class, they can apply that criteria. And then, in addition, it considers the weekday availabilities from the initial page.
One thing to note, I can go back, that search function up there, you select your, the classes header, I guess, so CSE represents computer science classes. You select that so that the database doesn't have to load the entire thing of classes. You just kind of segue to just CSE courses only. So we kind of optimize the search feature based on that. Yep. The next one. Okay, so then the schedule workbench is the final page. It lets you see your schedule, see your CRNs, and you have the 5 schedules up there. There are tabs. And then what's generated is down there. It actually now has text on those, but after you've seen that, each schedule is different. So you can have a choice between 5 or regenerate.
So just sort of to recap, you input your courses, and then the suggested courses that you had to choose from are based on your user input. And you can plan to take as many courses as you'd like and add those to the list. But if you don't, and your minimum credit hour limit isn't met, then it will automatically, based on an algorithm, choose your classes for you, and then allow you to cycle between, it'll do that a couple times, present you with a couple different options, and allow you to cycle through those.
We also have a lot of logic in the initial pages that prevents the user from entering in overlapping times or classes that don't work together, that sort of thing. And then this is our navigation bar. It lets you basically just go back into the getting started page, re-enter your information, or just go and view your schedules that you already have generated. It's extensible, so it works through every activity in the Android app. That basically means it won't start a million activities if you keep clicking the button.
All right, so these were the technologies that we ended up using to build our application. For example, we used XML to make the layout for the activities, and also store some values that we needed to hard code in there. We obviously used Android Studio to make the app, and Android Studio uses Java. And then for the database and the web scraper, we used a combination of tools, including, it was all coded in Python, but we had to use, we used a PostgreSQL database, and Selenium, which is, I'll explain later, and PhantomJS, which I'll also explain later, and scraping. And then we made all the graphics using Adobe Illustrator. All right, so the database. We used Texas A&M. They gave us a container for a CentOS server, which had a PostgreSQL database on it. So basically, my first task was to I developed the web scraper to get all of the class information from Howdy. And in order to do that, I coded in Python using a Scrapey framework. These are all open source software tools. And it's just a framework for scraping data from websites. But in conjunction with that, I had to use Selenium, which is an automated, it automates web browsers, basically. And then the browser I used was a headless browser, which is the little ghost guy, PhantomJS. And while I was scraping the data, I'd send it into tables that I had made with other Python scripts. Okay. And the server was just is just a basic TCP/IP connection over a socket. And essentially, you just have the Android client. It sends a command that I created like a little language for, I guess, to go to different various commands. And then it would parse those commands, and then make a SQL statement for the database, and then it would receive information from the database and send it back.
Okay, so I work on the back end. Like I said, I've developed an Android app before. I've worked on a lot of the algorithms and the logic behind the scenes. And
Right, even though Android programming was a new sort of area for me, my experience with my programming studio class not only familiarized me with Java, but also the agile software development process, both of which were invaluable in this project.
And I mostly did the server and the database and the web scraper. I would say that our 312 class on the threading class and stuff helped me with servers and also with parallelizing my database to make it run faster, or my web scraper to make it run faster. Because originally it took like 12 hours and that's not very helpful.
And I did a lot of design logistics early on. I was really active in trying to make sure that how it all went together in between contacting the right people that we need in order to get the resources.
There's a lot of red tape you had to go through Howdy and TAMU system.
And then just whatever else I could help out, or helped out some of the database. Mentor was money.
Yeah, and he is the Director and Chief Information Security Officer here at A&M. And it was very important that I got his permission first before I started, ignoring the robots TXT. He said it was okay. And he also helped get us dummy accounts because using my account wasn't really what I wanted to do in case I got banned. So he helped get us 5 different dummy accounts, and then I used a Scrapey framework. Also, I forgot to mention this earlier. It also has a server functionality where you can host a server and then you can send it commands. And I sent it commands from a bunch of different accounts in order to do it quickly.
It was important to have his permission to go into constantly getting on the site and making sure that it was working.
Yeah, scraping 15,000 classes or something like that.
Okay, so we consider ourselves concerned developers because, as with any development, you need to ensure that what you're putting out into the world doesn't affect someone in a negative way, and ensure that you're aware of what you're doing, basically. We wanted to protect the user as first and foremost. We felt that if we used their account, it would be great because you could make the schedule just pull everything off Howdy and they wouldn't have to enter anything. But that was a big concern because we have to keep it up with network security here at TAMU, make sure that it's all up to code. There's laws preventing stuff like that from being seen by other people. There's medical information, that sort of thing on Howdy. There's the user themselves probably don't want their stuff in some random app. And authentication through Howdy, we're technically a third party touching Howdy, even though we're Aggies anyway, but so now it drove our app in a very different way because now every user is anonymous. They don't have to enter any information that will make them personally identifiable. Anyone could have entered the same information. And we use publicly available data, though Howdy makes it way easier because you can get it all from one spot.
So we conducted user studies, and some of the results that we found from after they used the app.
27.
Huh?
27.
Oh, it's 20. We conducted 20 user studies. So we put, is it faster than Howdy? Like ability to use again. It was useful for searching and useful for enrolling. All of which you can tell and you can kind of see, but aside from this one, all the gray is green. The neutral is orange, and the blue is green, whereas the yellow is strongly green. As you can tell, we don't have much disagree. I feel the reason we have some of the neutrals because there are some people who just don't mind doing the regular way of writing down all their stuff and maybe making an Excel sheet. So they've always done it for 4 years, or I guess at this point that we've been for us.
So I will say that nobody disagreed that it would be useful for rolling. It's at least neutral, and mostly it's strongly agree and agree.
And really the important sort of tests there for defining our success were the top two, where we're determining whether or not the user believes that our service is faster than Howdy, than doing it, by some other means. And also that they would be likely to use it over other services.
So some of our future work, is we would like to expand and make this app a lot better. We would like to improve the scheduling algorithm, make it more efficient. Obviously, optimization is always something you can do. Add graduate level coursework, a little more diverse. Add a GPS route feature. That would be really nice for students who are building these schedules and maybe, book a building here and then have a class 20 minutes at tennis, like I had one.
There's also a lot of freshmen that probably won't know where any of the buildings are, and it would help them find their way.
And including language options and disability options for broadening accessibility. Additionally, we looked into all these and it's definitely a little more time, it's just a time constraint that we had.
Okay, so we believe that it addresses a real problem. We are students, and we built this for students. We went through the same troubles of signing up as anyone else here did, so we believe that our app was pretty much a success, and we hope it sees continued development, and actually people will use it in real scenarios in the coming future.
These are our references.
Not that important, just included it.
And we'd also like to thank Dr. Hammond and Raniero for helping us along the way and helping us with the help desk and
How stressful it was.
hardware and stuff.
Like in order from the security standpoint of view, in order to access that, we have to build upon the VPN access to the network, and then, or it's just like,
Completely external, right?
Yeah,
The server- Yeah, the server lives on the TAMU, so then users can access that because it's outside the firewall. The database, however, is in the firewall, so that lets users still access it while it's still secure within the firewall. Just as Howdy is accessible to
Okay.
anywhere.
all right.
Even the database.
You spent, it sounds like quite a bit of time screen scraping the data. Did you consider just asking for SQL dumps of the data you were
Yes,
looking
We
for?
asked
did,
for
yeah.
the degree planner, we asked for everything, and it was just like, I don't know, well, this and that, this.
We got a lot of, we're not sure.
It's
go
the
try
real
someone
world,
else.
though.
Yeah, the biggest thing too was the same thing with, like we said about the privacy, it was just a security issue, the time constraint to make something that we knew would be secure, doing it, because, we don't want to ruin anybody's lives.
We also don't want to crash Howdy.
Yeah,
It's very important.
So you guys did it, and y'all all finished enough, but did you use it in your own, for like your own scheduling this year to see if it would have been faster, easier, better for you?
We did look at I did look at test cases with it, but I don't need any classes, so I can't really sign up with it anymore, but I guess you guys, right?
Yeah, we've all tested it, personally, but not necessarily for our own intents and purposes, since at this point, well, he's graduating, we have 3 or 4 classes that we're required to take, and that's all we can take at this point.
Yeah, I'm
And
curious.
at the senior level, you only have like one option for each class, whereas you would have like 20 class times if you were a freshman.
If it were around when I was a freshman or sophomore or junior even, it definitely could have been something, yeah, for sure.
So do you think it solves the problem of helping create the schedule when there's lots of options and just presenting the data
Lots of
better?
options and not a lot of ways to sort of filter through those options.
There's a lot of prerequisites, that kind of thing. There's a lot of just empty classes that are just on there. I mean, you can obviously see them because they exist, but we don't need to show them that.
And in our survey interviews, we found out that a lot of the same trend was that people were saying, well, you open up Howdy and you look at the site, like kind of like how we showed you in one of the slides, and it's just this long list of lines of information, and it's a lot for people, and then it's also not graphically represented. So this, you can look and you swipe real quick and you can quickly see that it's already formatted in the same way that Howdy does it when you're finally finished and you've already done all the hardware.
So does this, is this more, do you see this more as a planning tool? And then the students still have to go through the registration process?
Because of the fact that they don't sign in, yes. But given the CRNs, all you have to do is enter those numbers. So you just take what you're given off the app and just enter the numbers in right as the registration opens. And if you were rejected from one because it's gotten full in the 2 seconds that you were on there, then you just enter the next set.
There is an ability on Howdy, I think, sort of tied into the class search, where when you're adding and dropping classes, they'll give you about 6 text, sort of editable text fields where you can quickly enter CRNs and submit to, try to add those courses, which is nice if you know the classes already, but you wouldn't unless you had done, some scheduling.
So, so you wrote this mainly for the student's perspective, to try to ease that?
Yes.
Yes.
Is there,
Oh,
is there an aspect of this that might be interesting in the university? Did you consider any impacts from that perspective?
Well, what I would say was, a lot of the times I found that it's when we're getting toward the end of the semester and finals coming up or projects are starting to hit, that's when you have to schedule for classes, and sometimes it can be like, well, I have to sit there and figure out what classes I'm taking, or maybe it's just inconvenient for you to wake up at that time and do that, whereas this takes all the information, you give it everything, one time, fill it to these, and you're able to move on with what's important, and that's taking your classes and making sure you perform the best you can each semester.
So that's the user's perspective. What about the university's? Did you guys consider?
This is sort of a stretch, but during add and drop week, there's obviously a lot of traffic on the site. Being able to load your CRNs quickly and just having a more efficient process in general would probably limit the amount of time that you spend on the site, and then as a result, reduce the traffic.
You guys, and I know that various like 436 classes and stuff, they commonly talk about how much they dislike the Howdy site or how it's inefficient, or I don't know.
Do you guys have any data that the university doesn't have?
We could probably generate some things about what users would like replace. So if there's a lot of classes that are being taken off of the automatically generated schedules, then people are, obviously something's wrong with that class, no one wants to take it, or they're trying to save it for some other time when there's easier classes. So I think probably metrics with what's signing up for what, that sort of thing. I guess they could probably make their own system with their data because it is their data, but ours would show what the user is taking off.
And I think it also helped to serve for some of those times where students are going from their sophomore to junior classes where they're having to do a lot of coursework class. Everyone's forcing at that point to try to get to this course, and then you have to open up more courses to the university to kind of say, hey, well, quickly, that's a course we need to open up more spots for, or we need to do more for. And if it's consistent over a series of time, they can make those changes for different majors.
So I'm just curious, what's the algorithm you guys use to deal with the prerequisite class? Did you guys use a topological solve?
Basically, the way we have it set up right now is it's maybe the most, it's work intensive, but it's probably the most effective way of ensuring that the user gets the right interaction with the app. But basically, right now we're manually constructing each degree plan, basically from TAMU resources. We're building their required courses and the prerequisites for each course from scratch as objects, and then using that in our application.
With regards to how you need to quickly input the CRNs and every semester people like a mad dash to type in their CRNs. I've heard that some students have been using bots to as soon as it opens up, put them in.
Yeah.
Is anyone aware of that? Have you all seen any of that? And do they have an official stance? And if so,
I know that I can do it with the screen.
Yeah.
Yeah.
So
If you just ignore the robots,
They told us to not, because that's, you can get kicked out and banned. That's why he didn't want to use his own account, so we had to use the dummy
It
account.
never would ban me, it would tell me please stop occasionally.
Yeah.
It's funny, first, against university policy to use bots to register for classes.
Yeah.
There are negative repercussions if you are found out in this case.
Okay.
you're where I heard that from, actually. Yeah.
Yes, I know. Two, one of the questions was.
They got permission.
They got
Yes,
permission,
we
which
got
is good. But if you were to,
From the head of
you know,
IT.
expand this to give it to everyone and use it as a pod, that would be bad. But there was a question about what information do you have that the university doesn't have? And I will tell you, one of the problems that we have is forecasting the demand of our classes. We just use historical data, and we don't really get the demand of the classes until students are almost done registering for classes. And by that time, opening up another section isn't necessarily something that we can do. If we had an idea of demand beforehand, we might actually be able to open such sections or close them to meet demand beforehand.
That's true, because I had to wait for about half of this summer until I could register for one of my classes this time.
And I had discussed with them about the problems of the length of the degree plan and having some way to be able to see that visually when you're
I think
in the curriculum meetings. That would be very, very helpful to see the unintended consequences of prerequisites in the length of the time the students are here.
Yeah, it's not really a question, but I think like my whole time here at A&M, when I've registered, I've only gotten successfully registered like once without an error. I don't know how you guys dealt with that, but it's a good feeling, so
Yeah.
that would definitely help. Yeah, for sure.
I'm about to graduate and I still haven't had a successful.
I had one, I think it was last semester, so. Yeah, no red text, you know.
So you mentioned about 15,000 course pages or something?
Yeah.
So how did you populate that list and fed it into the application?
Well, I created a big, like a table, called courses table, and then I created a table for each of the courses. There's 213 of them that inherit from that table.
This is the subject.
Yeah, for each of the subjects. Sorry, repeat the question again, sorry.
So, I mean, 15,000 pages, gathering those URLs is a pretty daunting task, right? So
Yeah.
how did you really guard those that URL list in the first place?
I just had it iterate through I saved each major, and then I just had it iterate through like, okay, select that first major, click on it, like get the length of the table, like the length of the classes, and just iterate through each one. And it was.
So programmatic.
It took a long time.
Was it a manual process or programmatic?
Oh, it was programmatic, but I had to, because it all followed the same pattern, so I had to get that pattern, by inspecting the pages and just having it iterate through that.
And we were considering that because even though we did speed up a ton, it's it's probably better to run it at where less users are on, and when run it once a day instead of like constantly. But that is 15,000 classes, so there is a lot to parse through.
Also, can you speak a bit more on how you use Selenium? Because, I mean, what I heard from you is a bit different from how the tool is used, but that impressed me, if I am getting it right.
I was completely new to everything. I had never coded in Python or done a web scraper or done a server or databases. So I don't know, I used Selenium I used the Phantom.js WebDriver, and then it opened up the headless browser, and I selected things by their path, right? And like, so table ID equals,
Right, so the purpose was to launch the page into headless browser and then read the content.
Yes.
I mean,
the Phantom.js is normally JavaScript. In Selenium, there is a WebDriver for Phantom.js.
Right.
So
that's what actually really interests me. Generally, people use Selenium for automation, test automation,
Yeah,
and of course it has a WebDriver, and you used that really very well for a different purpose.
Yeah, because you have to have a browser to scrape the data because it's loaded dynamically, so you can't just. Scrapey has what?
So you can't just get it.
Yeah, you can't. You'll just get a bunch of HTML with no data in it.